Philip, over breakfast the other day, you were telling me that the graph databases made by your company, Neo4j, were used by journalists in the Panama Papers investigation in 2016, which exposed a global tax evasion scandal that implicated heads of state. Could you tell me how GraphDBs were used and what they are?
Yeah, what was actually interesting in the investigation in this data leak was not, the legal papers and documents and who owned this particular legal entity, because many of the people in that database were actually trying to hide funds, and the way they hid funds was by creating a chain of entities which owned each other, and then having people who maybe shared an address or were spouses or were close business associates also obfuscate ownership through having their family members own things. And so even if you had just gone deep and analyzed it in any other way, you would have missed these connections because they were oftentimes many levels deep, like 10 levels deep. And so the ICIJ came across Neo4j as a way to take all the different entities and the relationships between them and essentially make sense of it and find the trail. So it's sort of like you're swimming in all this noise, and all of a sudden you can extract things and see the connections, and it just snaps. And you can still go to the website and see some of the visualizations and the ownership chains. And this had pretty big global consequences, like some prime ministers and ministers lost their jobs as part of this for having not disclosed assets that they owned. And that's really the heart of it, is that the world shows up as these complex networks, and if you can represent them as a graph, you can suddenly understand the way things are connected, you can understand the context, and you can understand cause and effect much more deeply.
So there's a whole database market. I guess there's SQL, there are like more traditional databases. Just to be clear, you're basically a direct competitor to those sorts of technologies?
It's competitive. It's also complementary. Starting in the early 2010s, there started being a lot of alternate models to the relational database, of which Graph is one. But you also have, column family document databases like MongoDB, key value like Redis. So when you're building systems, you oftentimes need different technologies to handle different specific kinds of data analysis. So there are certainly cases where Neo4j has been brought in to replace those technologies, but more often than not, it's just playing a role in a larger ecosystem of many technologies.
I think yesterday you said that if people were designing databases from scratch today, they would probably design a graph database.
That's right.
What did you mean by that?
What I meant is, if you're trying to design a database to solve the problems that show up in today's world, well, the kind of data that you need usually is some digital real-world system that I need an agent to understand, and where I actually also need a common understanding amongst multiple agents. Like one need look no farther than Moltbot, Moltbook, OpenClaw, whatever it's called today, to see the kind of chaos that can occur when you don't have some central grounding force, both from a reasoning and from a to kind of fight against the entropy that otherwise descends. And given that the world tends to show up as networks, whether it's biological, ecological, networks of payments, networks of computers, networks of people, ideas, spread of disease, or as hierarchies, which is a specialized form of network shaped more like a tree, org chart, asset ownership, supply chain, that if I want to solve for those problems, then ideally I would want a representation that is shaped in the same way those show up in the real world, which is a graph. And then likewise, modern compute has evolved greatly from the time relational databases came into being. So the reason you have a rigid structure is partly because they were designed to solve business process automation and digitizing paper forms at the end of the day, but also subject to the constraints of memory, spinning disk at the time, where you couldn't just randomly chase across data to connect the dots to understand larger systems. You sort of had to narrow the aperture. So for most applications being built today, a typical application you should start, certainly consider a graph database to start with. And in my estimation, probably at least half of applications should start with and use a graph database at its core.
I think that's pretty compelling. I'm a former engineer, and the nerd in me rejoices to hear that this idea of graphs being a kind of natural representation for the world. But the journalist in me notices that graph databases currently account for about 2% of the global database market. Why is that, do you think?
Exponential curves start slow. It's like the drip, drip of water in the stadium, and 30 or however many iterations later, when you're doubling it, every time, it looks like the water is barely, filling the base of the stadium, and then you blink and it's all full. So part of it is this the average database management system from the research I've seen is deployed, and then that application and its database live for about 7 years. And then you also have people who are taught in school to think and learn in a particular way, and it takes some time for them to make their way into the workforce and see things differently. So the database space is one that's particularly, I think, slow to move relative to certainly consumer tech, and there's a whole spectrum between that. But what gives me assurance is I'll point to two things of several. One is almost every developer that I've seen work on a project with Neo4j will start to see the world in graphs, and will start to see how, oh, the world is networks. What am I doing putting it into tables? It's so much more natural and easy to work with once I've learned to think in that way and work in that way. And then on the other end, standards oftentimes define the next generation of technology. And after more than 30 years of having just one ISO standard for database management systems, namely SQL, ISO around 2 years ago, April 2024, released a graph database language standard which defines the property graph model and which defines the language around it, which is called GQL. And this is more or less looks very similar to Neo4j's Cypher language. You can use Cypher and have assurance that is GQL compatible. And so that, at these two extremes, developer adoption and the behavior of a developer once they've gotten into the tech, as well as ISO standards define the next generation of technology. They're not meant to define something that's just going to be around for a year or two. As well as the fact that AI applications, in order to be successful in the enterprise where you have a higher bar for success, it appears that you need something like a knowledge graph, for which the best implementation is a graph database. And then last but not least, AI makes it easier to overcome some of the hurdles that have always existed for people to adopt graphs, namely learning the language. Well, now you can just have agents translate human queries into Cypher or GQL queries. And likewise, creating the graph, AI is really good at taking on what was previously a piece of heavy lifting.
I want to come back to the AI question, and we should definitely speak about that. You mentioned exponential growth being slow at the beginning, but it's always exponential. I mean, has Neo4j's growth been exponential so far?
Yeah, I joined, so I was having a dinner with a VC a couple nights ago, and we were talking about Neo4j. I've been at the company around 14 years. We raised our Series A just over 13 years ago. And he kind of sat back and he said, look, it always takes 12 years before a company is even known by anyone. And then everyone thinks it's an overnight success, and this thing just turns around. So in the time I've been there, I joined sub-million in revenue, and before anyone knew about the category, let alone the product. Now we're in 84 of the Fortune 100. We have hundreds of startups that I know of, hundreds of AI startups that I know of just in the last few months that have signed up to our startup program. Any startups, I'd welcome you to do that. And some of the biggest buzz in AI in the last few weeks has been around knowledge graphs and context graphs. So I feel like, and to answer your question, as far as the growth to date, we've gone from sub-million to, at the end of last year, we crossed 200 million in ARR, and we were last valued at 2 billion. So definitely the growth curve has been like that.
I've managed to go 11 minutes of this talk without saying the word context graph, which is, I think, the title of the panel. Can you, give a little more detail on what that is concretely, what a context graph is?
Yes. So a context, very simply, is, and we all know what it means, just kind of in human language. It refers to, tell me not just facts about this thing, but give me knowledge about things around it, where that thing came from, how that thing behaves, and then perhaps how the things around that behave and the things around that behave. And if I look at it maybe a bit more rigorously, you could look at at graphs at having several different layers of context or kinds of context. At the highest level, you hear about context in the world of semantic layers. And this refers to where does the data come from? So you have the context for a piece of data, which one definition is, well, what system did it come from? And when was it last updated? And who updated it? So that's one kind of context. The other kind of context is, let's take an example in consumer web, and I'm wanting to give a recommendation to someone. They have 3 things in their shopping cart. What should they put in next? Well, I'll do a better job of recommending the right thing if I understand what things do people usually buy together when they've already bought these things. So that's the context around those things. What has this person bought in the past? Have they bought these things together? What have family members in their household bought? What are things they might have returned? Okay, let's probably not recommend that one. So that's another form of context around the actual domain of the data. And then there's yet another form of context, which is what's a lot of the AI discussion has been around the last few weeks, which is why was a particular decision made, understanding that, so that in the future I can use that information to make better decisions, either by capturing the rules and executing those rules deterministically, or by informing an LLM and bringing that context in either as pre-training or as part of the prompt to make a better LLM-informed decision in the case where the reasoning happens there. And what you can do with this, which ultimately is what's valuable, is once I have one or more of these different kinds of context, which, by the way, each interrelate with one another, but you can start small, and once you have it, you have essentially a source of knowledge that machines can read and execute on, and then humans can also understand. So it becomes a bridge between human knowledge and AI knowledge, human volition and AI, whatever it's going to do. And it can also become a layer that's used by multiple agents so that they can coordinate with each other, so that they all aren't just looking at different parts of the picture. Like I think about the classic ancient Indian tale of the 7 blind men and the elephant, where each one is touching a different part of the elephant. It's like, this thing's like a snake, and this thing's like a brush, and this thing's like a tree trunk. And this is what you get with agents that are each using silo data that's disconnected, so it can give you that as well.
Does this picture of the context graph fundamentally change the work that Neo4j is doing? Does it change the technology that you're building, or is it basically just a new application for the same technology?
It fundamentally changes the stack that it participates in. And so to that degree, then it changes everything at the connectivity layer in runtime, what systems need to connect with it, including like having an MCP agent, layer and connecting with agents. At the development time layer, it changes, it offers new possibilities for developing in terms of code assistance. So we've capitalized on AI for helping users write queries. It also changes, I'd say, the altitude at which you use the graph. So many applications historically have been, I'm going to use the graph for one application or one use case. And then over time, you would end up with a particular enterprise using, having lots of different graphs, and then they might bring them together or federate queries against them. And here, what I'm seeing a lot more of is the pattern of, let's deliberately go in, kind of at a CIO, CDO, CTO level and say, we actually need an organized store of knowledge distinct from data. Like you may have a data lakehouse somewhere where you've put every bit of data, but that's not suitable for real-time access and shared knowledge, nor does it know anything about the connections. Typically, it's hard to do multiple joins, let alone multi-hop, let alone transactional. And so having a system of context that agents can access, and it supports both applications, so transactional access patterns in the database, as well as analytics, where you can actually run graph AI, so supervised and unsupervised learning, like Google was the first, I think, big commercial example of this, of PageRank. Let's rank order all the search pages based on how many inbound links I have from other pages, and then weight those based on the number of inbound links. So there's a whole rich set of graph theory and graph algorithms that can be applied on the analytics side to actually enrich your context based on taking what you know about the topology of the graph and how things show up in roles that individuals, nodes, or actors play, and feeding that back into your AI system. So it's a way to also bridge all of the kinds of AI that we've yet invented alongside Gen AI to make your Gen AI applications more powerful.
Here's a totally different question, because we have time for one more. My friends and I sometimes talk about what our post-AGI job would be. What we would do if artificial general intelligence tomorrow solves all the problems and we can just sort of do whatever we like. What would your post-AGI job be?
What would my post-AGI job?
Yeah.
Well, let me first say that I don't feel like AGI is necessarily helpful as even a mental model, because it assumes that there's sort of this one monolith that will do everything perfectly and give you perfect answers. And my experience, particularly in B2B and in the enterprise, is there's not just one thing or one intelligence that is operating as part of your AI system or your application. You actually have a composite of big models, small models, each with checks and balances playing different roles, of course, knowledge graphs and other tools. And so to ascribe general intelligence to like one part of that, which is the LLM, seems misplaced. Okay, having said that, what would I do? I would apply myself to seeing how we can not use it as a crutch, but using it as an amplifier of our own human agency and our own action and creativity. I was in a conversation a few weeks ago with some people who worked with foundation models about, how do you get LLMs to answer certain kinds of questions better to help people navigate their lives better. And one of the things that we realized is you actually don't want the LLM to just hand someone the answer on a silver platter. That's super irresponsible, because then we just become automatons. We don't, that's how many more steps do you have before we're all encased in pods in the matrix with some jack in our heads? So I would work to enable AI in such a way that it supports and enables human potential, however intelligent it may be.
Cool. Thank you.
Thanks. It's a pleasure.